So once again, I welcome all. In last lesson, we have seen that the zeros of a second degree polynomial or a quadratic polynomial are the x-coordinate of the intersecting points of the graph and the x-axis. Okay. So next question is, how many zeros will be there? That's a question. Okay. So for first degree polynomial, we have seen there will be exactly 1 0. There will be exactly 1 0. But for a second degree polynomial, there can be 2 zeros, and there is another chance. There can be 1 0, and also there can be no zeros. 3 chances are there. It depends on how the graph looks like. The graph always looks like this shape, but the bottom, this corner of the graph may be the top of x-axis, and sometimes it may be a different way. We'll see that. Before that, one more thing. So this is also taken from textbook. That means for a second degree polynomial, the shape of the graphs looks like this or this. Okay. So this shape is called the parabola. You can see in textbook. The parabola. Okay. So it's an important shape. The name should be in your mind. Parabola. Parabolas means graphs in this shape. Okay. Not semicircle. A little more curved. Okay. Now here one more thing you can note here. If a is equal to 0, it is opened upwards, and if a less than 0, it is opened downwards. A means the coefficient of x square. A means the coefficient of x square. In both examples we have seen here the value of a is 1, a positive. So the graph is open to upwards. And for the first example also, a is 1, a positive value. X greater than 0, so it is opened upwards. And suppose it was minus x square minus 2x minus 3. If the value of a, the coefficient of x square is minus value, negative value, then the graph will look like that downwards. Okay, so simply keep this idea in your mind. Then next thing. So now we will look at how I told that there can be 2 zeros and 1 zeros and 0 zeros. So to explain that, I will show you some pictures. Sometimes the graph may be like this, upwards or downwards, but intersect x-axis at 2 points. Yeah, so definitely we will get 2 zeros. The x-coordinates of both the intersecting point are zeros. So we'll get 2 zeros. Okay, upward or downwards, no problem. The intersecting point in this picture is marked as A and A dash. A dash and A. Okay. So the x-coordinates of A and A dash are zeros of given polynomial. So if graphs comes like this, if the graph intersects x-axis at 2 points, there can be 2 zeros. And sometimes the graph may be like this. The center, or not center actually, the tip of this curve may be simply touching the x-axis. So there will be only one intersecting point. Okay. In picture you may see that it shares many points with x-axis, but if you zoom the line, you can see it exactly touches only one point at x-axis. Okay. So here we will get only one intersecting point. So we want to take the x-coordinate of that intersecting point, that will be 0. So in this case, if graphs comes like this, we will have only 1 0 for second degree polynomial. Okay. And the third case is sometimes the graph may be like this. It may be completely on top of x-axis or bottom of x-axis without touching x-axis anywhere. Okay. In this case, there is no intersecting point, so we don't have to go for any x-coordinate of intersecting point. So there are no zeros. If the graph doesn't intersect x-axis, there will be no zeros. That's the geometric idea. Geometric idea is zeros are the x-coordinate of the intersecting point of the graph and x-axis. but here there is no intersecting point, so there can't be any zeros. Okay, so what all we discussed today? The zeros of second degree polynomials, the geometric idea, and we have seen a special shape for a second degree polynomial, and we name this shape as parabola, and we see that these graphs intersect x-axis at 2 points. 2 points, so there can be 2 zeros, and sometimes it may intersect only at 1 point, so it can, the second degree polynomial can have exactly 1 zero, or it can have no zeros. Okay, so 3 situations are there, but in all the situations the graphs are parabolas, not that. Okay, so the graphs are always a parabolas, but depends on the position, the peak of the graph. There are 3 cases, and number of zeros can change. Okay, can the number of zeros be more than 2? Any chance?
No.
No. Anyhow, only 2, maximum 2 zeros are possible. So we conclude the idea: a quadratic polynomial can have either 2 zeros or 1 zero or no zero. In other words, a second degree polynomial has at most 2 zeros.